Sample problem in crystallization for heat and mass transfer. A feed solution of 10,000 pounds at 130 degrees Fahrenheit containing 47 pounds ferrous sulfate per 100 pounds total water is cooled to 80 degrees Fahrenheit, where ferrous sulfate heptahydrate crystals are removed. The solubility of salt is 30.5 pounds ferrous sulfate per 100 pounds total water. The average heat capacity of feed solution is 0.7 BTU per pound degree Fahrenheit. The heat of solution at 18 degrees Celsius is negative 4.4 kcal per gram mole or negative 18.4 kilojoules per mole of ferrous sulfate heptahydrate. Calculate the yield of crystals and make a heat balance. Assume that no water is vaporized. The solution will have crystallizer, the reactants, products, S for solution, C for crystals, and we'll use basis of 10,000 pound per hour of feed. We'll start with the overall balance. Overall balance is just reactants equals products. So in this problem, we'll have 10,000, the feed is equal to S plus C. We'll use this for ferrous sulfate balance. In ferrous sulfate balance, we'll have 10,000, which is the feed, times 47, the amount of ferrous sulfate in the feed, over 147, the total amount of ferrous sulfate and water in the feed. This is equal to S, an unknown variable, times 30.5, which is the amount of ferrous sulfate in S, over 130.5, the total amount of ferrous sulfate and water in S. This plus C times 152, the molecular weight of ferrous sulfate, over 278.02, the molecular weight of ferrous sulfate heptahydrate. Calculating this, we'll have the values for C and S. C equals 2,750 pounds of ferrous sulfate heptahydrate crystals, and S equals 7,250 pounds of solution. We'll go now to heat balance with T1, or the initial temperature, or the T in, which is 130 degrees Fahrenheit, and T sub O, or final temperature, or T out, which is 80 degrees Fahrenheit. We'll first convert the heat of solution from kcal per gram mole to BTU per pound. So we'll have negative 4.4 kcal per gram mole times 1,000, which is the conversion of kcal to cal, over 278.02, the molecular weight of ferrous sulfate heptahydrate, times 453.6, the conversion of pound mass to grams, over 252.16, the conversion of BTU to cal. Calculating this, we'll have the answer of negative 28.47 BTU per pound mass of ferrous sulfate heptahydrate crystals. Now we'll solve for the enthalpy of feed, which is the H sub 1. So we'll have 10,000, the feed, times 130 minus 8, the change of temperature, times 0.70, the average heat capacity. Then we'll have the answer of 350,000 BTU. Next, the heat of crystallization, the H sub 2, we'll have negative 28.47, the heat of solution, times 2,750, the amount of crystals, which leads us to answer of negative 78,300 BTU. So now we'll have to compute for the heat. So heat Q is equal to H sub 2 plus H sub V minus H sub 1. In this problem, the H sub V, which is also the enthalpy of water, will be equal to 0. So this leads us to Q equals H sub 2 minus H sub 1. And calculating this, we'll have the answer of negative 428,300 BTU, or negative 451,900 kilojoules. Since Q is negative here, heat is removed. So that's it for the sample problem in crystallization for heat and mass transfer.